I don't know. It's a thing. No comment. Okay, good. Last problem. Man, I think we're taking too much time.
Mr. Rose.
What's up?
It's because you can just put them together. Yeah.
No.
No, because the thing from that to that is r minus big R minus little r. It's not root r squared.
Okay. Wait. We have two more big things to do. Should we do this torus problem or like not? I feel like I kind of don't feel like it. Should we do it?
No.
No, you don't want to? Okay, good. All right. Let's take this homework. Sorry, I ran out of time. Let's take this homework, and we're gonna do two new things now. So let's hand in the homework. I'm over there at the table where no one sits. Chip, you okay?
Thank you for recording. Great, my name.
Oh yeah, it's my friend's wedding.
Whoa, buddy.
Fun. My brother got them a present, and it's a picture of him with a picture of me and him, and they're not even in it. Wait, Michelle. Put water bottle there.
Okay.
Hold it like where my head would be.
Good. We are now going to learn two things. Are you pumped?
Yes.
Griffin, tomorrow.
No, I can't. I was working with one like really early.
Oh.
Still recording.
Yeah.
I like 8 o'clock.
Okay.
Jermaine, wake up. This is like the most dead class ever.
I told you we're tired.
I'm dead.
Mr. Rose, which side?
If I put music on YouTube, will like find me.
We should go outside.
It has to be obscure music, like Shire's Band or something like that. Okay, good. Griffin, give everyone one of these.
They won.
Okay, guys, we're doing a 5-minute warm-up. Ready? We're just gonna go really fast. That'll wake you up. 5 more. Wait, Griffin, give me one.
All right.
We're doing this. We're doing this thing at the top of. We're doing this quick review 7.3. Ready? Quick review 7.3 is going to review the area of crap. Will, are you pumped?
Yeah.
Yeah. What is? Please give me a formula for a square if the sides of the square are of length x.
X squared.
Damn, I think the answer is x squared. How are we feeling? Good. That was a good one. Number 2. That was like a warm-up to the warm-up. Number 2. What if the square has diagonal x?
2. Yeah, another one. Root 2x. Yeah, 2x.
You are screwing up. If this is x, then using geometry, what's this?
2x squared. X root 2.
This is, or I think this is, no, it's not x root 2. It's definitely not x root 2. This is bigger. The hypotenuse is bigger.
X squared over root 2.
Yeah.
Oh, yeah.
Wait, yes, this is x over root 2, right?
Yeah.
Because you multiply the length of the hypotenuse is root 2 times as long as the length of the circle. Adisha, any good now? Yeah. So if that's x over root 2 and that's also x over root 2, then the area of this thing is going to be? X squared over 2. Yeah, that feels right. And it is right. Number 3, a semicircle of radius x. Be done in 5 seconds. Pi x squared over 2. Agree?
Agreed.
Just like duh. Just the area of a circle and then divide by 2. Okay, good. Number 4. Also, period 8 is watching this video because we had back-to-back fire drills. So, look nice. A semicircle of diameter x. If the diameter is x, then the radius must be x over 2. Yeah. So then the area of the entire circle would be pi x over 2 squared, but then we also need to divide by 2. So I think the final answer is pi x squared over 8. Brilliant. You guys are so great. Good job. Number 5. An equilateral triangle with sides of length x. Go. You have to like know some basic facts about the world. If that's x, then that's x over 2, and then what's the hypotenuse, or what's the height?
X over 3.
Root 3 times as much as that, so that's x root 3 over 2. And therefore, the area of this thing is 1/2 base, which is x times height, which is x root 3 over 2. That's like a formula that some people know. It's x squared root 3 over 4. Have you seen this before?
Pretty sure.
Kellen, you good?
Yeah.
I'm doing this warm up for you, not me. I know these things already. Number 6. Do it. Answer. Yoni, can you raise the board? Isosceles right triangle with legs of length x. So it's just like x squared over 2, right? Boring. Number 7. You are so correct. If that's x over root 2, so that's going to be just x squared over 4. Am I going too fast, too slow, or both? Number 8.
It's just twice the. It's like squared root 3 over.
Yeah.
Okay, I mean, it's just basically a simple geometry problem. So if I drop a perpendicular, then that's x over 2, yeah? So you need to figure out what the missing side leg is. Okay, if you want to be cool, then you just think of this as a 1, 4 something triangle, but then just divided by 2. So if this is 1 and this is 4, what's this? Too slow.
3.
15.
Root 15.
Root 15, good. So if that's root 15, then this is just that triangle like scaled down by like,
Root 15 over 2.
so this is root 15 over 2x. Yeah? So answer is 1/2 x root 15 over 2x. Final answer, root 15 over 4x squared. How are we feeling? Good, 9. By the converse of the Pythagorean theorem, if the sides of the triangle are 3, 4, 5, then it like must be a right triangle, right?
So that's x squared.
Be bold.
Yeah. So it's just 6x squared. You agree?
Garrett has something to say.
Okay, number 10. Garrett, something to say?
No. Never mind.
Good. Number 10.
It's
It is.
x squared root 3 over 2.
Yeah, if you're experienced with hexagons, then you know various facts about regular hexagons, such as that they are decomposable into equilateral triangles. So if the side length of the hexagon is x, then the fast way to do it is to just recognize that it's just like 6 of the number of those number 5s. So it ends up being 3 root 3x squared over 2. Is that right?
Yeah.
All right, awesome. Do you guys feel pumped up with warmed up on how to find how to do the area of things? Okay, good. Now I have a lesson which only takes 5 minutes. It goes like this. Who would like to star in this lesson?
Jimmy would.
Sure.
Garrett.
Okay, Jimmy.
This is for you, Jordy.
Okay. So, all right. This is called volume by cross sections. So we are going to find the volumes of things, but now the things we are going to find the volume of are not solids of rotation. They are instead solids whose cross sections follow a certain pattern. All right, so I think the best thing to do is to go straight to number 2. Should I do number 2? Let's go to number 1. Let's go to 1B. All right, and never mind the directions at first. I'm just gonna like tell you what's up. Here's what's up. Jimmy is a real estate
Novelist.
what's the word?
Magnate.
Magnate. Thank you.
What?
Real estate magnate.
Yeah.
It means you're I don't know what it means. I don't even
Oh,
know.
that's
I don't even know.
investment.
Yeah.
Oh.
Basically, yeah. And you are going to buy. So you buy a particular plot of land. Yoni, the particular plot of land that he buys is the unit circle. It's a highly prized plot of land.
It's like a ticket.
Okay, so you now own the unit circle, and it is time for you to build build your empire. And what you're you paying attention?
Yes.
Okay, good. So you're going to build a building, and you're going to build it on the plot of land. And you would like the building to go like this. You would like cross sections of the building perpendicular to the x-axis to be squares. And you are going to build within the boundary of the land that you own, which is not that much. Someone drew a car on this whiteboard for some reason. All right. In other words, to the maximum extent possible, when I cut his building with a plane, the shape is going to be a square. In other words, what we really are going to do is we're going to draw a line, and for every one of those lines, we're going to have coming out of the board a square. And what is the height of that square? Not x. The height of the square is going to be whatever the length of the line is, basically, right? It's going to be like that. Is everyone seeing? And when the square is kind of tiny over here, then we're going to have a tiny square coming out, and then the biggest the square ever gets to be is 2. So the height of the building is like 2. Is this okay? Okay, good. So how can we solve this problem? Answer with integration. We need to just know what the length of this line is. So given an arbitrary x value, what is the length of this line?
2y.
This is the unit circle x squared plus y squared equals 1. So if this is the unit circle x equals 1, then the height will be
1 minus 1 x squared times 2.
root 1 minus x squared times 2. Yeah. Okay, so what do we do with that? So the length of that red line is 2 root 1 minus x squared. And then what do we do with it? Square it, says Kellen. If we square it, now we have the area of a cross section. And then let's just give it some infinitesimal thickness, like dx, and then add them up. And we're going to go from what to what? -1 to 1, or if we want to be cool, we can go from 0 to 1 and then multiply by 2. Does anyone follow this? Okay, whatever. Let's just do it. So that's 4 becomes 8. Did you guys get 16 thirds? Is that a yes?
Yeah.
Okay, good. Okay, cool. Alternate plans. That was 1B. 1C, alternate plans, says let's not build squares. Or no, we're going to build squares, but now we're going to be Oh, by the way, you can have a lot of fun depending on your powers of like visualization, 3D visualization and art skills and stuff like that, imagining what this shape looks like. Well, first of all, you have a worksheet which kind of shows it to you, but like, someone want to like,
Yeah, it's like a.
is it sharp? Is it smooth? Is
No,
it, what's it like?
ugly. Correct. Like. Like, I don't get how to
Is it
say
smooth or
it.
is it sharp?
It's like, yeah, smooth, because there's an infinite number. There's like an infinite number. It's just like a
Smooth where? On the top?
Yeah, it's like a bubble.
How about on the edges though? Like, because like squares are
Edges
sharp.
flat up here. Edges,
corners are all
it
different
looks like a.
But they still have like ink.
Okay, good. 1C. 1C says instead of building squares which come out of the board, Jimmy. Now we're going to build underground layer and overground. So now you still own the unit circle, but now you are going to build squares. Pictures with 1,000 words is on your paper. You're going to build squares whose, as it says, cross sections are squares with diagonals in the xy plane. In other words, cross sections perpendicular to the x-axis are squares, but they like go under the ground, right? So I still pick an arbitrary x value on the x-axis. I still draw the maximum extent red line. It's still the case that that red line has length 2 root 1 minus x squared, but now that is the diameter, or rather diagonal, of a square. So I take the length of that red line, and then what's the area of a square with that as a diagonal? Take that, you divide by root 2 to get the side of the square, and then square the whole thing. And then give it a little thickness, and then add them all up, and again I'll go from 0 to 1 and multiply by 2. Okay, I don't feel like actually doing it. 1D. 1D says now, same plot of land, but now he's going to build a shape such that cross sections are equilateral triangles with bases in the xy plane. So I draw a line for an arbitrarily chosen x value. The length of that line is still 2 root 1 minus x squared. But now that is, does everyone see the equilateral triangles like coming out of the board? What do you get? Or how do we do it? How do you find the area of an equilateral triangle whose base is of a particular length? Like we did that over there, right? So I'm going to take the length of the line, which is 2 root 1 minus x squared, and what do I do with it? Squared root 3 over 4, and then just give it a little thickness. Integrate from 0 to 1 times 2. Brilliant. Okay, good. A couple more. Let's just do like 2 more. Yeah, 1 more. Let's do 2B. 2B. Now we need a new person who I'd like to star in the second half of the story. Aditi Shetty.
Mateo.
Aditi Shetty purchases the parabola x equals y squared between x equals 0 and x equals 4. Excellent choice. Excellent investment.
Have fun with that.
And given this, I suppose I should like shade regions and crap like that. Griffin, can I get the green marker? See it somewhere? I know. Oh, it's right on your table next to you.
Oh.
So,
Well, fine, Jimmy.
So Aditi Shetty owns this region, and what will she do with this region? Answer: she will build a building such that cross sections in the xy plane perpendicular to the x-axis or something like that form squares. And so this is, what did I say this curve is? X equals y squared? Yeah. And so now I draw a line. What is the length of that line for an arbitrarily chosen x value? Yeah, 2 root x, right? Achilles right, yeah? Because if that's x equals y squared, then for a particular x, the height will be root x, so that's 2 root x. And then, so what does Aditi Shetty do? She takes the length of that red line, which is 2 root x, and then just squares it, right? Square it, give it a little thickness, integrate from 0 to 4. Okay, do you want to look at this for a minute? Let's do it. Can someone pull down the, erase the board, pull down the shades, turn off a light, turn the camera. What's up?
It's like the
That's screw up?
It's like the circle thingy, right?
There's no pi, I'm doing 2B. I'm doing 2B. I skipped 2A because it's kind of boring, because it's we know how to do that a different way, right? Yeah, so I skipped, that was 2B. Okay, good. There are some just like awesome things out there on the internet. Can you pull the screen down? Let's see. Have like bookmarks and stuff. Oh man.
I
Wonder where it is. I wonder if I have it. Give me like 5 seconds.
Richard Montgomery.
Don't look too carefully, David.
No.
Stop making that weird noise, whatever that is, it's disturbing.
Share stuff you can do.
Why me, Griffin?
Why always
Because you're the one who has to get it.
Huh? Interesting. Crap, should I just like Google it?
Yeah, probably.
Man, I had it somewhere. Cross-section demo. Yeah, here we go. Cool. Okay, awesome. Check it out. So this is pretty close to what we were doing. Here, what we have done is we've taken a particular arch, we've taken a particular hump of sine, and we bought the plot of land from 0 to pi in a sine curve, and we built a house which is such that cross sections are triangles. Looks really cool, right?
It's like really uncomfortable.
terrible color choice.
This is like 1987 type. Yeah. Start with that. Okay, let's do some more. Let's do this one. Now we're taking a quarter circle and we're building inside that quarter circle a building whose cross sections are squares. Is this kind of helping to visualize things?
Yeah, it is.
Should go lower.
No, it's not really. Oh, yeah. Well, 1987.
This reminds me of like.
Okay, beautiful. Should we do this one? This is the one. This is one of the ones we talked about. Now we take a circle with whatever, and now we're building a building such that cross sections are equilateral triangles. I think. What does it say? Oh, right isosceles triangles. Oh yeah. Sorry, I didn't actually read it. Angles like a little bit weird. Well, I thought that was like another kind of cool one a little bit. Maybe that's it. Okay, but actually, it's better to go here. Oh my god, this is so old. How do I do this?
You just said that, Richard.
Wait, I want.
Let's go. Happy.
Yeah, here we go. And we can also look at washers, by the way. So here, I don't even know what's going on. It's some weird shape. And that's that we shade a region. We partition the region up into subregions. We take a representative rectangle and we rotates that representative rectangle about the x-axis, producing a washer. Isn't that pretty? So, 1998, cutting edge. Go faster. Website. And then, is that all it does? Might do more things. Yeah, that's it. And then, wait, let's see. I feel like there's a couple more that are cool. Oh, should we look at it the other way? The other way of thinking about it is we partition it up into, and then this is showing all the partitions one at a time. This is showing all the washers, you see? Of course you do. Cool. And then I think it's going to rotate them now. Yeah. Jump, 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 jump. Look at that shading. Look at that high quality shading going on. So beautiful. Wait, we're totally like running out of time now. We look at like one more? Or are we good?
No, one more.
I'll link you to this page.
No, let's look at the right top right corner. That's the one for the homework, right? From the packet. No, not that one. Down.
They can get re-elected in their positions.
Yeah,
That's the 4 minus x minus x squared, and then x squared.
Yeah, now this is the one where it just does it. Okay, meanwhile, we have another thing to do. Are you ready? If you must. Okay, light back on, thing back down, and let's, someone find the remote for the thing, turn it off, and take out a fresh piece of paper, and you please do the following problem. We have exactly half an hour, which is not enough time, so we will not succeed. It's exciting. So, please do the following. Find the volume of the solid form by rotating about the y-axis. The region in quadrant 1 bounded by the x-axis and the line y equals 2x squared minus x cubed. Go. Read the prompt very carefully. The mom has to get it right. What's the word? Alright, so I can factor out an x squared. This is x squared 2 minus x, and I should probably write that as like negative x squared x minus 2. Do you guys have a graph this thing going? Like done by now, should be. So let's see. If I try to graph this, I know something about this. This is a cubic. I'm an expert on cubics. There's going to be a, first of all, it's a cubic, but it's negative leading coefficient, so upside down. So end behavior like this, double root at 0, root at 2. So it's going to be coming down, a little kiss on the x-axis, back up again, and we're jump down. Is that what you got?
Yes.
Okay. And first of all, what region is being discussed? Enter the region in quadrant 1, bounded by this curve and the x-axis. In other words, the region of interest is like this one. Do you agree?
Yes.
Once I recognize that that is the region of interest, the rest of this curve is not important to me anymore. What am I doing with this region of interest?
You are rotating it around the y-axis.
I'm rotating around the y-axis.
So you're taking sideways rectangles?
Okay, so, thus, using everything we know at the moment, how do I have to draw my rectangles? How do I partition this?
Horizontally.
I think I have to go sideways again because I'm rotating around the y-axis, right? So if I'm rotating around the y-axis to make my washer, I have to go sideways. Okay. You don't seem to be crying yet, though. If you're not crying, it means you don't get it. Can someone do a ceremonial cry for the rest of the class? Whoa, okay, stop. Alright, good. That was not crying, but it was a good substitute. Okay. Crying on demand is an important life skill when you get pulled over by cops and stuff like that. Alright, so, like for speeding. Griffin, why should we be crying? Lathrop, why are you crying?
I have an idea why we shouldn't cry.
Oh wait, no. First we need to cry and we need to get it all out. Yeah,
I
Lyle.
don't know like how far to integrate along the y-axis.
You don't know like where the.
Oh, that's the least of our troubles. Yeah, he says I don't know how far to go up. Well, I could probably, yeah, you're right. I probably have to like do some calculus and stuff and figure out what that relative max is,
It's
right?
not 1 to 1.
Okay, but it's actually worse than that.
It's not 1 to 1.
Yeah, because it's worse than that because what I'm doing is by drawing my rectangle sideways, what I'm essentially doing is, what I must do now is pick a arbitrary y value on the y-axis between 0 and whatever that point is. I agree we have to find it. But even worse, man, I need to know if I'm going to revolve this around the y-axis, I'm going to get a washer, right? I need to know both the inner radius and the outer radius of this washer. Well, how am I going to do that? I mean, you did a lot of problems like this for homework, but like, are you guys seeing the issue?
Yeah.
This equation is like a no gross, right? I mean, this is bad. No, comma gross. No, I don't want to do it because it's gross. I don't know how to find the inverse of this. In fact, this is like pretty much impossible without like a cubic formula or something like disgusting and terrible to be able to do this. Yeah, do you have something to say?
Can't you find a relative max and then instead of having one washer, you have a bigger washer and then a smaller washer?
No.
I can find a relative max. In fact, I have to find a relative max in order to do was it you that said it? Yeah. In order to do what Eli said, which is to find out the y value so I know what it's up to. But that doesn't particularly solve my problem. I don't think the problem is partitioning it. I think the problem is just finding out. I just don't know. Straight up, just like don't know what that is, right?
Yeah.
For a particular y value.